classes that we teach here at our school. He's an astrophysicist, and he's actually been to Caltech and Harvard. Today, just to close the webinar, because I know for the East Coast people it is getting on past 9 o'clock in the evening, he's actually going to briefly talk about our physics courses that we teach currently here at Areteem Institute, as well as as Kelly, our director, had mentioned, we expanded the curriculum. So he's going to introduce some of our new topics now. So now I'm actually going to get Dr. Ragozzine to appear with us.
Hello, everyone.
And here is Dr. Ragozzine.
Yes, hello.
Hi, Dr. Ragozzine.
Hello. I'm glad to be here with you today and to talk a little bit about Areteem and what we've been doing. And thank Vishenk for that very nice introduction, and talk a little bit about what we're doing here in terms of physics. So as is mentioned here, I'm an astrophysicist. I study planets around other stars. And I'm very interested in helping students. Several years ago was a student very much like you, and at that time we didn't have very many resources. I did go to a math summer camp, but at that time MathZoom and our team didn't exist. And one of the reasons I'm really excited to be involved with this process is to help you to realize what you can do to develop your potential. We've heard a lot about passion tonight, and I think that is really important. But what can often happen, I came from a very small town, for example, and at that time there were no opportunities to really explore and develop my passion for physics and astronomy. And so I make this joke about how I lived in a small town in southern Utah and there wasn't an astrophysicist within 100 miles. And then I went to Harvard, and there they have the Center for Astrophysics, and now there were 100 astrophysicists within 1 mile. And it is an interesting change in perspective. But now, with the way the technology is, those limitations are no longer that important. I have actually mentored students, high school students, in research projects from across the United States. And these kinds of things are opening up the opportunities. And the beauty of that is, if you have a passion for math or passion for physics, through MathZoom and Areteem, you can develop those and you can go deep into those subjects. And again, in terms of college applications, as we've seen before, that's something that is really impressive when you have gone deep into a material by taking extra classes, by doing well, by participating in and ideally doing well in competitions, and also by doing research. And so I just wanted to mention a few of the classes we have on the physics side. Let's see, Cameron, if you give me whiteboard access, I'll take it for a little spin as well. We have about 4 different levels of physics classes right now, and we have several different levels of math classes as well. And sort of the physics classes that we have physics fundamentals, which is similar to a high school physics course, given in 4 different sessions. So for example, here in the summer we're going to be talking about modern physics, which is one of those 4 sections. And we are very excited to announce that we are now going to be teaching AP Physics C classes, mechanics, both the mechanics portion of that exam and electricity and magnetism. We're teaching those as separate courses, and the idea here is to actually have courses that are designed and strong enough that they can you can take those independently of taking any high school or college curriculum and be able to do well on the AP Physics exam. Vishenk mentioned that we also have classes called Physics Challenge 2 and Physics Challenge 3. These are focused on, Physics Challenge 2 is focused on doing well on the USA Physics Olympiad preliminary exam, also known as the F equals MA exam, as well as doing well on the Physics Bowl and other Science Bowl related things. Physics Challenge 3 is for really focusing and doing well on the semifinal exam. But these courses, the great thing about these courses is that these courses that teach you both not only physics but also how to think about physics and getting a deeper understanding of physics, they will help you when you take your physics courses in colleges. You'll find that the type of thinking and way that you learn how to do math and physics at Areteem and the way that we teach it is the way that you will learn, the way that everyone else has to learn in college. Once they get to college, they have to do problem sets and write out their explanations and think deeply about questions and understand them at a deeper level. And we are able to prepare you to do that in middle school. So we're very excited to offer these physics courses, and especially this new AP Physics course. We also have a very exciting thing I'm really excited about that I'll be teaching this summer, which is, there's already been some discussion about doing research. In my opinion, if I had to say that there was one thing that could really really strengthen a college application after developing some depth in a particular subject, it would be to do research in that subject. That's what real scientists do. That's what I'm doing. Right now it's the summer. I'm not teaching any courses as a professor. I'm doing research. I have students who are helping me do research. And there are many opportunities for doing research even in middle and high school. You have to find the right person to work with, and you have to have the right kind of topic, but you can do research even at a very young age, and I wish I had known that. I expended a lot of effort on doing well on various math competitions that I feel some of that effort would have been great to put towards research. Well, one of the main things, the first thing I look for when a student comes in and says that they want to do research with me, the very first thing I ask is, do you have any computer programming experience? Because even though you might think that math or physics is the first thing to know, those things are absolutely prerequisites as well. Most students coming to me know a little bit about astronomy before they walk into my door. But all I do all day, all an astrophysicist does all day, more or less, is write computer programs to analyze their data, or to explain their theories, or to develop their models. And so we're very excited to be offering this summer, for the first time here, a Programming for Scientific Computing course. And this course is going to be taught in a way so that people who have very little or no experience in computer programming can kind of get a little bit of a taste for it. And it's focused really at thinking about, if you take up a standard programming class in college or elsewhere, the focus will be able to teach you how to program. This course will also cover how to program, but with a focus of applying it to scientific computing. And it's the kind of thing that you can take to that professor that you want to work with and say, hey, I'm interested in working with you, and I have some computer programming experience, and you can ask my teacher, Dr. Ragozzine, about that and things like that. The language of the scientific computing language is actually called Julia. And it's actually a new language, but it's a really exciting one because it's specifically designed for scientific computing. It's very similar to MATLAB or Octave, and Julia is an excellent introduction to this topic. And so we're very excited to be offering that for the first time this summer. And I think we'll go ahead and turn the time back over to Cameron, and if there are any other questions, I'll be happy to answer them during the Q&A session.
Thank you, Dr. Ragozzine, for coming on today.
Yeah, it's good to be here.
Awesome.